Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I am learning quickly, I don't claim any real expertise. Today, we're looking at the 49th Project Euler problem. As always, I link to the problem and my repo in the description. Let's dive in. Problem 49 is prime permutations. The arithmetic sequence, those three numbers in which each of the terms increases by 3330, is unusual in two ways. Each of the three terms are prime, and each of the four-digit numbers are permutations of one another. There are no arithmetic sequences made up of 1, 2, or 3-digit primes exhibiting this property, but there is one other 4-digit increasing sequence. What 12-digit number do you form by concatenating the three terms in this sequence? So, I believe this means that we need to use the number 3330. So let's go ahead and copy this entire problem statement for today. Going ahead and formatting this so that it's easier to look at in this particular Okay, so what 12-digit number do you form by concatenating three terms in this sequence? I'm guessing the terms increasing by 3,330 is important here. Go ahead and copy this. I'm actually going to remove the year, month, day. We just care about the timestamp. And then I'm going to create a prime equal to... Actually, I'm going to call this is prime. And I am going to have it be of size... See, I'm going to set this to true is capital T in this language. True times, let's see, we want all the four-digit numbers. So... first fifth-digit number is 10,000. out the first two. And then for range, okay, so now I'm going to go ahead and look, because I remember doing prime number stuff before many times. I'm going to look back into my library. Here we go. Okay, not that one. Here we go. I think just this part. No need for this. Okay, so what I am doing here is I am going through for every number. I'm going to get to whether it is prime. Start with the square, so I'm going to mark off for the number 2. I'm basically going to set our Boolean array every even number to false, and then go through and do that with the multiplies of all prime numbers. And then what I am going to do is for n in range, starting with 1000, going to limit, or actually I feel like we can just do limit minus 6660, which does not leave us a whole lot of room, but should be more than enough time. Okay. So if n is prime, we want to do n1 is equal to n plus 3330. I'm going to go ahead and say increase by, have this be a variable. Okay, so now I have n, n1, and n2. Arithmetic is cheap. So, if all three numbers are prime, then I want to I'm actually going to go ahead and say if n is equal to 1487, then we want to continue. We're going to skip the answer that we know we don't want. So now we have to check whether things are a permutation. Okay, that's not really what we wanted. Okay, so looking back at our previous problem. So what I am remembering is we had a previous problem where we were checking whether a number was a permutation of itself. Oopsies. I remember using this variable name before. Let's go find it. Nope. Interesting. Okay. That's fine. Okay. So, this is technically a pretty inefficient way of doing this. But, because I know that these are only going to be, like, size 4, I think it'll be fine. Say if r of n is equal to r of 1 and rn1 is equal to rn2. And actually, can I just do this? I think I can just do this in Python. Sequence equals and then we break out of the for loop, and then we print out the sequence, and the joined version of it. Okay, so problem 49.py. Okay. Okay, this that's what I get for naming it as if it were a method. Okay. Let's see if this is the correct answer. As we can see, it came to that correct answer basically instantly. Go, and it is the correct answer. Okay, so let's go back through our method. So here's what we did. We said, okay, we're looking for 4-digit number. So we only need to care about digits up to, or numbers up to 4 digits long. Or up to 5 digits long. I think I included 10,000 in here, but that's not a big deal. I used the what's it called? The sieve of this guy to find the prime. Actually, let's go ahead and so basically this is an algorithm where, oh good, it's going to show us a little animation. We start with the number 2. Number 2 is prime, so we go through and we set as false all of the multiples of 2. And then this animation is taking a while, but next we would go up to the number 3 and set as false all the multiples of 3, so on and so forth, until only primes are left. And it is a faster way of finding primes because it's literally just like, I think it's n log n. And it's easy to kind of skip over looking at tons and tons of numbers that you don't need to think about again. But that's how, again, maybe not the most possibly efficient way of doing this exact problem because we only care about 4-digit numbers and I'm looking at like 10,000 numbers here. But it's just a very, very quick and easy way to set things up so that I know when I come in here, we skip 1487 because that's the one in the example and we're looking for the one that's not that. We calculate what the next 2 items in the sequence would be. We check if all of them are prime, and since these are just like lookups to a Boolean array, it takes no time at all. I mean, obviously it takes microseconds, but, you know, basically takes no time at all. We convert our ends into strings and string arrays for each digit, sort them if they end up all being the same. We set them out to the sequence and break out of our for loop and print everything out. So pretty straightforward methodology going on here. Obviously we found the correct answer the first try after, you know, making sure our code compiled. But yeah, that's it for today, and I'll catch you in the next one.